Welcome dear friends, this is Matt Doctor and today we are going to discuss about number systems and how we use and how computer interprets and various applications of number systems we are going to discuss in this lecture. So watch carefully what we are going to discuss. So there are two types of number system we are going to discuss. Actually there are only four, there are another two also types of number system. So whole there are four types of systems. So now in this lecture we are going to discuss binary number system and decimal number system and how computer interpret uh, output as a binary number system and change it from decimal system which we input to computer. So how computer understand, we know that it understand in a 1 and 0, and this is going to be defined our binary number system. So this is going to be called a binary number system. So 1 and 0 are included in it. So it has two subscript. Subscript implies the number of digits we are going to use in that system. So in decimal number systems we are going to use 10 numbers for uh, for making our digit. For example, we are going to write 23. So these are the number, these should be pronounced at 23. But in this case when we going to write 10, it is in binary or in decimal number system, we have to know. So before going to start, I am going to tell you the exact pronunciation which we are going to take in any number system except decimal system. In decimal system we are going to pronounce the 23 whole, 234 as 234. And in the binary number system or any other system we are going to pronounce it as a single digit. We are going to pronounce it as 1 and 0. This is 1 and this is 0. So in any other system which we will discuss later, there are two other systems which we are pending in this number system topic. So we will discuss it in the next lecture. So there we also call whole digit by whole number by one. We don't call it by whole, we take into parts, and we actually call single digit our number. We call it as a which we have defined here. We have defined only 1 and 0. So 1 and 0 we only know that it should be included in it. So we are not going to take as a whole as a whole number. We are going to call it as a 1 and 0. So this is the actually topic. This is the concept we are going to use for explaining our binary number systems and decimal number systems. So let's begin. So first of all, we are going to convert binary into decimal. How we understand binary into decimal? So let's discuss it. So before we going to know the binary number system, we must have to know that binary number system indicates the power of 2. We split our number. Let's take an example of 23. We split into that numbers which are easily divisible by only 2. So for example, 2 raised to power 2, 2 raised to power 3, and many others. And like we have to remember that the 8, 16, and which are only divisible by 2, which are divisible by 2 raised to power some x, 2 raised to power x, some for natural number, for whole number. So for whole number actually 2 raised to power 0 is defined as 1, we know that. So it may be it should be separated into that numbers which are divided by only 2. So here we are going to separate it with 16. We have to know that the nearest of it, the nearest digit which are divisible by only 2, we have to split first number to the nearest one. Then we have to come down and it's half maybe. We are going to check can we add 8 here. If we're going to add here, it will become one more, which is 24. we don't want to take it. We're going to take 4, and which is less, which makes us 20 as a output. And again we are going to take 2, because 2 raised to power 1 is 2. We are also going to take that. So again, now we are seeing that it's not completed, so we are going to take 1 also, so that our 23 will arrive. So how we represent this 23 in a binary number system? So we are going to take, and how computer interprets it as a binary number system. Computers, some softwares are which are known as compilers, which convert binary number system, decimal system to binary number system. So here we are converting from decimal to binary. So first we are going to look at, so 23, let's look at converting this into 2 raised to power 4, 2 raised to power 2, 2 raised to power 1, 2 raised to power 0. So the power which are there, we have to note that. So power is where we know the powers, we have to write that place 1. So 0th place 1, we write 1. 1's place we write 1. 2's place we write 1. So there are 3 digits, but 3rd place is not there, so we write 0, and also here we write 1. So this is going to convert from decimal to binary. So this is not going to be easy first. So let's look at also how we convert from binary to decimal. So we are going to take example of 110. So how we convert from binary to decimal system. So let's look at it. So 110 indicates that it is 2 raised to power 0, 2 raised to power 1, 2 raised to power. So we have to note its array from right actually. So these are the notation, these are the powers of 2 which we are going to take. So first of all, we are going to take with left hand side 1 into 2 raised to power 2. Okay, so then we are going to add plus 1 raised to power 2 raised to power 1, because its place is 1th place, and we are going to start from 0. So this is multiplied with 2 raised to power 0. So this will be cancelled out, and we are left with 4 plus 2, which is 6. So binary of it is 6. So the compiler in the computer actually convert binary system to decimal system. So this is going to be the case in computers. So we must have to understand what exactly happened inside the software. So that's why we are going to teach this number system. So in different types of, in semiconductors we are going to use hexadecimal systems, and in computers and more digital electronics you will use it. So but basic computer will understand binary first. So you will also notice in my next lecture that each and every electronic, either we have to convert from decimal to binary, decimal to octa, and decimal to hexadecimal. We have to go through binary. So binary acts as a base unit of it. So that's all about binary. Binary is included in each and every type of system, either it's computer or electronics. So this is going to be very much useful. So here we will notice that in this 1 and 0, can we write each and every real natural number or whole number in mathematics? So the answer is yeah, we daily write that, and it may be easy to write, but we are going to, computer can easily write that, but it can write a bigger number in a smaller amount of. So this is going to be very big number. So when we go through that, it's not even possible to do by hand, by our calculations. So it's easy to do with that. Computers can easily convert from these numbers. So compilers are there. So we are going to learn about how we convert from a binary to decimal by our hand. So now we are going to do this. So this is going to be right 1. So can we, now we are going to discuss, can we write each and every type of number? So let's look at, so with 1 and 0, can we write 1? Yes, you can write 1, which is nothing but 1. And you can write also 0, which is 0. And you can write also 2, which is 1 and 0, 2. Okay, so this is going to be writing 1 because 2 raised to power 1 is 2 and plus 0. And this is going to be 3. 2 raised to power 1 plus 2 raised to power 0 into 1. So this will not cancel out. So let's look at more example of converting binary into decimal. So this is binary. So here we have to take as a 0, 1 and second place from right hand side, and just put 1 into 2 raised to power 2. These are going to be powers. Okay, plus 1 into 2 raised to power 1 plus 0 into, because this will cancel out, so it has no meaning, 4 plus 2 plus 6. So this is going to be answer of this. Here we have not 0, here we have done with 1. So we are going to write here 1. So that's how we get our maximum of it, which is 7. So that's how we are going to use it. So if you have any query, we have also discussed about it for converting decimal to binary and binary to decimal. And let's look at one more example for converting decimal to binary. Let's look at 12, how we convert 12. So first of all, before we are going to start with, that's why we have to know first convert from binary to decimals. What actually binary indicates. So we have given 1 0. We have to call it 1 0, not 1 or not 10. Then we have to convert it to 2, which we already know how we convert it. So this is going to be 2 raised to 1 into 2 raised to power that's place. If it is here 1 0 0, then it's going to be 4, because 2 raised to power 2 plus 0 into something else, 2 raised to power something else will definitely 0. So we have to note only one and its position, and where its position lies, we have to make its power and 2 raised to power something else and multiply it with 1. So we answer will arrive in 2 raised to power something else. So now we are going to take another example. Can we write 4? Yes, you can write also 4, 1 0 0, and also write 5, which is known as 1 0 1, and you can also write 6, which is 1 1 0, and you can also write 1 1 1 is equal to 7. So this is going to be done with the binary number system, because we are discussing about this type of system in our for converting from decimal, which are whole numbers, in. So is each and every we have to first of all define that each and every number should be arrived by using only 1 and 0. So this is going to be this is the interesting fact about it, that we can convert from each and every type of by using arrangements of 1 and 0. We can convert each and every type of whole number in mathematics which we are using. So that's how we are going to done with next lecture with hexadecimal systems. So now the last question is about converting decimal 12 into binary number system. So this is, first of all, we have to split into dead numbers which are only divisible by 2. Only divisible by 2. For example, 8 plus 4. Okay, 8 plus 4. So 8 plus 4 is 2 raised to power 3 plus 2 raised to power 2. So this is the array of 3, 1 1 and 0 0, and this is going to be answered in binary. You all know, because this represents the third, this represents the second, this represents the 1, this represents 0, and here we don't want 2 raised to power 1, 2 raised to power 0. If we have given 13, then we definitely 8 plus 1 plus 4, then we write it as 1101. And for 14, we definitely write 1110. And for 15, we definitely write 111. So this is how we get each and every number in only 1 and 0. So this is the very useful for don't take many actually inputs for computer, so except 0 and 1. So it's convenient for computers for getting 1 and 0 as an input and convert into that particular by using same algorithm, same steps to reach the final conclusion which we have input in our decimals. So that's the main idea of using binary number systems and how computers can easily identify it with using these calculations easily. So this is going to be happen. So next lecture would be on two pending our number systems, which are hexadecimal systems and octal systems. So those are also important, and this is going to be a very important concept for proceeding with next lecture. So keep watching my channel, my lecture regularly, and follow my channel, subscribe it, and share with your friends so that you can easily gain some you can easily gain knowledge about the mathematics and anything else like in and mathematics related subjects, physics. So you can gain knowledge about it. So that's about it. So thank you to all of you. Watch my lecture regularly. So please subscribe, hit the bell icon, and thank you. Meet with you next lecture. Thank you.